Hello, my name is Christopher Costello. I'm a professor of natural resource economics at the Bren School at UC Santa Barbara. This is part of the Sea Grant project on the West Coast Groundfish Fishery between the University of Washington and the University of California, Santa Barbara. And this particular paper is co-authored with Corbett Granger of University of Wisconsin, and it's called Catch Shares and Regulatory Capture Over Fisheries. I'm recording this on July 7th. Let me start by giving you a sense of what this paper is trying to do, and then I'll get into the details. The basic premise of this paper is that when you switch a fishery from a non-catch share, such as a limited entry system, to a catch share, such as an ITQ, you change the incentives of fishermen to influence the regulator to increase the catch. Essentially, when a fisherman has a long-term secure right to catch fish into the future, they tend to favor the future more than they would if they had a very weak property right or an insecure future. We think that occurs when you implement an ITQ. Basically, because a fisherman is guaranteed to be a shareholder in that fishery's catch into the future, and even if he decides to retire, he knows he can sell his right. That creates a strong property right or a very secure future, which creates an incentive for him to try to influence the regulator to more conservatively manage the fishery, to put more emphasis on the future than on the present, at least compared to the case where the property right is very insecure. So we're going to develop a theoretical model that in fact comes to this conclusion, and then we're going to try to test it with a global database of fisheries. So let me start by talking a little bit about regulatory capture. Our notion of regulatory capture is that every fishery in the world has some mechanism by which the industry can pressure the regulator to change the total allowable catch. So even though there's a fishery manager who ultimately sets the TAC, fishermen always play some role in influencing that fishery manager. What is the fisherman's incentive to do that? Should they always lobby for a higher catch in the current period at the expense of the future? Well, the answer is obviously no. If the fisherman knows that he will be a residual claimant, or he'll be the one who can benefit from conservation actions today, because catches in the future will go up, then if they're very secure in that right, then they're likely to lobby the regulator to more conservatively manage the fishery. On the other hand, if their rights are very insecure, for example, if they only have, let's say, a few years, a permit that's only good for a few years, or if they're nearing retirement and they can't pass their permit on to their son or daughter, or they can't sell their right, those are all cases of insecure property rights, then they're likely to lobby the likely to lobby the regulator to manage less conservatively, to catch more today at the expense of the future. This is all in theory. What we'd like to do is develop a model that generates predictions such as these, and then test it with a global database. So our questions are, how do catch shares affect industry pressure to change the total allowable catch? And how do catch shares affect the aggregate fish catch set by the regulator? While we won't study any one fishery in detail, we'll study lots and lots of fisheries, almost 200 fisheries, over a long time period to try to answer these questions. So we need to first develop a theoretical model, and the reason we need to do this is we need to generate some testable hypotheses, so we'll know what to ask of the data once we collect our data set. So what we do is we start by generating a bioeconomic model that combines the growth rate of fish with the incentives of fishermen. And we start with the sole owner model, which is a model, it's sort of a mythical model that doesn't really exist anywhere in the real world, but it provides a nice benchmark. The sole owner is a single fisherman who owns the fishery and can determine the amount of catch every period. They have to delicately balance their desire to catch more in the present period, in the current period, with their desire to catch in the future. If they catch all the fish today, then they catch less in the future. If they catch nothing today, they can catch more in the future. So they have to delicately balance these two desires, and a sole owner would do that. They would appropriately balance in a sustainable way the current period with the future periods. It now contrasts that with an industry that has weak property rights, and we're thinking about this as an industry without catch shares. So this is an industry that has very insecure property rights. Maybe they know that for the next 10 years they'll be able to fish, but they really don't know if they'll still have the right after that. That industry may have a strong incentive to catch more today than would the sole owner. In contrast, an industry with catch shares may have strong property rights and therefore may want to lobby the regulator to reduce catch today or be more conservative. So the regulator has to think about how they're being influenced by the current fishing industry, but also how they will be influenced by the future fishing industries. So they have to think about how they want to weigh the future generation's interests with the current generation's interests. Let me tell you a little bit about our theoretical results. The first thing we found is that a captured regulator who manages in the way that our theoretical model predicts will choose a harvest policy that is similar to the harvest policy of a sole owner, but they'll apply a higher discount rate. And what that means is that they have to factor in not just the usual discount rate, the rate of time preference, but also they have to factor in the insecurity of the property right given by theta and the different weighting they give to current versus future generations given by gamma. When they apply a higher discount rate, that means they favor the present more than they would if they had a lower discount rate. So what we get is an upward sloping control rule. So we predict that they will allow a harvest that's increasing in biomass, so higher biomass, higher harvest, which seems sensible, but that this rule itself will depend on the strength of property rights. If the property rights are weak, they'll allow, in a sense, too much harvest. If the property rights are strong, as they would be with an ITQ, then they ought to allow a more conservative or less amount of harvest. This is a graphical depiction of that, and I don't want to spend too much time on this, but I have harvest on one axis and the biomass of fish on the other axis. And the blue line is the harvest rule that the theory would predict that the captured regulator would allow. So that's how much harvest they would allow for any level of biomass. So more biomass allows more harvest. And the blue dot is the steady state. That's where you might reach that point and sort of be able to sustain that level of biomass and that level of harvest over time. If you compare a catch share fishery, which is given by the lower blue line here, to a non-catch share fishery, which is given by the higher blue line, you see that the catch share fishery, at least in theory, would tend to have a lower catch rate. And this is all, again, based on the theoretical model, based on the principles from economics of regulatory capture, but also on the bioeconomic model we developed. This is, somewhat interesting from a theoretical perspective, but whether it has any practical relevance or any empirical relevance, or whether it's actually playing out in the real world is a big open question. So that's where we're going to go next. So let me turn to the empirical analysis. The goal is to estimate whether fisheries that are managed with catch shares are more conservatively managed than fisheries without catch shares. So what we're going to try to do is estimate those blue lines from the previous figure. We're going to try to estimate how fisheries are actually managed and look at whether catch shares lower that control rule or make the fishery more conservative. We're going to look at 178 fisheries from the RAM Legacy database in 27 large marine ecosystems. These are all over the world, and these all have stock assessments, which is necessary because we need estimates of biomass and the catches over time. One of the nice things about this database is we're going to be able to utilize the rollout of ITQs over time and space. So we can look both cross-sectionally at fisheries with and without catch shares and look at changes in their management or their harvest rates. But we can also look at a single fishery before and after implementing an ITQ or catch share and ask whether it becomes more conservative the day after it gets implemented. We will examine 3 different statistical approaches to look at this question. The first is a cross-sectional regression, the second is a non-parametric regression, and the third is a panel regression model which exploits the rollout, allows us to test both before and after, and catch share versus non-catch share fisheries. The first is a cross-sectional regression, and the basic idea here is use the most recent year of data for every fishery in our database. Some of those fisheries have catch shares, some of those fisheries don't have catch shares. And the question is, holding biomass constant, is the catch rate lower for fisheries that have ITQs? And the answer is yes. ITQ fisheries are more conservatively managed than non-ITQ fisheries, and on average they're about 20% more conservatively managed. The second approach is called a non-parametric regression. Here we only look at fisheries that have ITQs or that eventually switch to an ITQ in our data set. And we look before the ITQ and after the ITQ for each fishery. Now, because they all switch at different dates, we're going to normalize the date to year 0 in the figure I'm about to show you, and we're going to separate out the effects for fisheries that are overfished when the ITQ is implemented and fisheries that are healthy when the ITQ is implemented. And here are the results of that non-parametric analysis. At the switch date, at date 0, the overfished stocks tend to reduce their fishing pressure significantly when the ITQ is implemented. After for healthy stocks, the ITQ fisheries tend to increase their catch rates after the ITQ is implemented. And these both seem to make sense and seem to accord with the theoretical model. In the overfished case, you want to rebuild the fish stock after you implement the ITQ, and that seems to be exactly what's happening. If you're underfished or you're a very healthy stock, stocks above BMSY, you tend to want to fish them harder after the implementation of an ITQ, and this seems to suggest that that's actually occurring. So our story would be that the industry, in the healthy stock case, the fishing industry is saying, the stock is healthy, let us fish harder, and the biomass still won't be in jeopardy and we'll make more money, and the regulator is agreeing with that. At least that seems to be the case with this global database. The third approach is the panel regression model, which allows us to directly estimate the causal effect of implementing ITQs on the harvest rule chosen by the fishery manager. The question is, holding biomass constant, does implementing an ITQ lead to more conservative management? And what we find is the answer is yes, at least for low levels of biomass. So when biomass is low, let's say B over BMSY of 0.5 or 0.4, a fishery that's really in need of rebuilding, ITQ managed fisheries are about 20% more conservatively managed than fisheries without ITQs. At high biomass levels, let's say above BMSY, there's little or no difference between ITQ and non-ITQ fisheries. So the conclusion is that it seems that from the theoretical model that strong property rights, such as ITQs, ought to affect the outcome of regulatory capture. Even though the regulator is choosing the harvest, she's influenced by the industry, and the industry, once they have ITQs, have a strong incentive to favor the future, which means they ought to lobby to more conservatively manage the stock. In fact, that's what we find empirically. Fisheries with ITQs are more conservatively managed than those without ITQs. And this result seems to be strongest for stocks that are in need of rebuilding. And thus, for those fisheries, implementing an ITQ will likely rebuild those stocks more quickly. Thank you very much for attending, and I look forward to the live Q&A chat where I'd be happy to try to address any of your questions or concerns about this research. Thank you.